Hola, animigos, and welcome to Keyframers, the animated collaborative coding livestream where we bring imaginative user interfaces to life. I'm your host, Stephen Shaw.
And I'm your host, David Khourshid.
Together we are coding compadres, animation amigos, Boolean buddies, and keyframe companions.
Yeah, so as always, we're going to be creating an animation from scratch live using HTML, CSS, and a bunch of JavaScript, maybe, probably. We're happy to answer any questions you may have, like why are we using so much JavaScript? So please reach out in the chat or comments.
I'm thinking we can get it to 30 lines or less.
So much JavaScript.
30
Unbelievable amounts of JavaScript.
30-line guarantee.
For your money back.
Exactly.
Except you, Patreon.
Yes. So, yeah, this should be pretty cool. I'm excited about it. So the animation today is going to be based off this reactive typeface by Daniel Brandt Olson. It's a relatively straightforward effect. We've got kind of this grid of repeating text, and it kind of interacts with the mouse. The distance from the mouse kind of determines the scale of the letter. So yeah, I mean the goal here is to use some CSS variables and keep kind of the JavaScript calculation to a minimum, and try and pass all that to the CSS variables for them to use.
Right. So we haven't done too much thinking through this. We did do a little bit of thinking through, but I'm guessing the math is going to get a little hairy. And by hairy, I mean we had to remember middle school math for this, but it should be fun. So the idea is we get the mouse position. That's a XY coordinate, right? And we somehow have all the positions of the centers of each of those letters, which are also XY coordinates. And then you do a little Pythagoras and you find the distance between the two. And you set that distance on each one as a CSS variable. And then you could basically change the effect to however you want. And that's the beauty of CSS variables. I mean, I've seen this effect in the wild, or effects like this in the wild. It's all manually done with JavaScript, and you don't get flexibility when you do that. Like if you have to deal with media queries, reduced animation, or prefers reduced animation, any other type of customizability, that sort of just goes out the window because you have to do it all in JavaScript. And with this approach, since we have CSS variables, you're free to do whatever you want. We're just giving you values. I think it'll take a lot of JavaScript. Shaw thinks it won't, but let's see what happens. It's like the Price is Right.
That's right. So one of the first things we're going to need to do, normally I would just kind of reach for splitting, and we'd do that for just having the characters split up in spans for each of them. But I'm actually going to do a manual split here, David.
Oh gosh.
So let's say const L text grid equals document selector text grid, and then what we're going to do is L text grid. Oh, let's do function split light.
So why not bring splitting into this?
Well, so one of the things with splitting is there's not currently an option just to do characters. Right now it splits words and the characters, but I would like to just use grid for the layout here, and so splitting each individual character within the scope of the larger grid parent, rather than like trying to incorporate subgrid and all that. So, right. So basically let's say let text equals L.inner text, and then we're going to go text.split, and this is going to give us the characters. And we can map over those. And
why is it var for variable and char for character? This is a hill I will die on. I feel like those are the wrong pronunciations.
you don't pronounce it character?
Character?
Yeah.
This is text setting, not Pokemon.
Yeah.
Charizard or Charmander or whatever.
Something like that. Let's see. We can just return this.
So you're going to manually create elements for each of those characters, characters,
right? Each of the characters.
Okay, makes sense.
Span equals char.
Okay.
Char equals.
Now I know we're going to run into problems if we don't do display inline block. I think I've run into this before, and anyone could correct me if I'm wrong, but if you don't put an inline block on the span, then when you try to get its bounding client rect, it's going to report the width and the height as 0 or something like that. It's a little bit weird. So so I just preemptively added inline block.
Yes, we will definitely need.
Why it does that?
Need that because for transforms and stuff too, we'll need to style it that way. L.html equals .join.
So I'm also going to throw in a little grid over here. And let's see. There we go. Cool. Right, so and I also probably want to center that.
Putting light on L text grid. And we should see a bunch of squares. Aha! Success. So this is essentially what like the prototype of splitting was. It's just kind of splitting up each character in there. Really straightforward. But the problem with that is like as you get into special characters or like trying to calculate words and like doing more advanced things like this isn't really a great approach. But we can return the characters there, and now we have. That's not. The problem is those aren't real character elements, so we can query for them after, because we're going to need to basically detect the position of each of these after this splitting happens. So let's say let L characters equal L text
I
grid.
don't know how to count. I totally thought that there were 9 characters in keyframers. There's 10. There we go.
Yeah, and I think I miscounted here as well. I was thinking 8. I think we need 2 more rows. Bar chart.
This is fun. This is like a really messed up crossword puzzle.
L.style.set property bars characters.
Cool. So again, we're not manually adding styles. We're just adding those CSS variables onto there.
Oh.
Whoa! You made it tiny. Jeez. Okay. So I'm using vmin in order to basically make it fill the screen, whichever is smaller.
I'm adjusting that now. There we go.
Okay.
All right, and that should help. We're probably gonna want
like 90 vmin or something like that.
Yeah.
Okay. Say no more. 80. See, I try to get all precise with the math over here, and then we end up adjusting anyway. We're not pixel pushing, we're viewport unit pushing.
Yeah.
There we go. That at least that works on my screen.
6, 7, 8, 10. Okay. Yeah. Let's remove that row. There we go. That I guess we have 11 in here. something like that. Okay, there we go. Wait, we need one more and then just K. Sure. Okay, that works. Were you a Nintendo or a Sega fan growing up?
I would say Nintendo. I don't remember too much of my game playing past. I don't really play that many games anymore, or any really.
Now that my daughter's of an age where she can appreciate video games, we've been getting back into things a bit more. That's been fun. But growing up, I was very much into Sega and all that. And one of their ad campaigns was "Welcome to the Next Level." I think it was maybe Sega CD or something like that. But it had this awesome text grid, kind of like this, where it was too small for any one word to actually like fit on one line, and so it kind of wrapped around and was like horrible for readability, but just looked so cool. Thanks, Daryl. Every time I get a notification that you guys are live, Lionos chat comes to mind. Yes. All right, so you're creating a map down here.
Yeah, and so it's actually not going to be elements clients rect. I'm thinking rect clients rect distance number. And so basically what's going to happen is every time that we,
see, I was thinking we do the distance calculation in CSS, that we only update this char map whenever there's resize or
how do we
like
calculate distance in CSS though? Because you need square root, you need all that fun stuff.
Do you?
You do.
Are you
Indeed you do.
Sure? You might be right on that.
Yeah, so just better to do it that way. So I'm also going to add the document add event listener, and we're going to do a mouse move. So again, the idea here is as the mouse is moving, we're getting those clients X and clients Y. So I'm going to grab clients X, clients Y. We're grabbing those values from the event, and I'm just going to console.log the client X and client Y just to see that that works.
A little compatibility there. .add.
Yep, no, I fixed that.
Okay.
All right, so yeah, we do have the clients X and the clients Y.
Yep.
Okay, cool. So now every time that happens, we need to basically update the, we need to go through each char map, and you know what? That could probably be an array. I don't know why I'm making it a map.
Yeah.
Okay, we'll just make it an array. So we have L characters, L characters. Yeah, let's make it simple. So we're gonna say const char measurements equals L characters dot map. Is this an array, or do I need to array dot from?
Array dot from. Yeah.
Okay,
and
so for
pro tip here, array dot from. The second parameter is a map function, so you can just leave that off, and that will run per character.
All right, so we're going to have an array of objects where we have get bounding clients rect. So we have the reference to the element, we have the rectangle, or the bounding client rect, and we also have the distance. For now, it's going to be 0. I don't know if that's a good idea, but
yeah. So one thing we can do is okay, you can fit this way.
Yeah, so every time the mouse moves, we're going to recalculate that distance. And so we're going to do two things. We're going to recalculate the distance, and then we're going to set it as a CSS variable. So we are going to say, all right, how do we calculate the distance? Oh, there's const distance equals. You could do that, but I'm going to blow your mind. Ready? There's this math.hypot function, which actually I was about to blow your mind, but now I have to look up what that actually does. But basically that does all of your Pythagorean craziness and figures out the distance for you. So let's see, is it multiplied? I'm trying to figure out. Oh yeah, so I guess it's just like m dot x minus clients x, m dot y minus clients y, and then that's going to give you the distance, I think. So yeah, let's just test it out. So dot set property, what do you want to call it, distance?
Yeah.
And we're just going to give it that distance.
Right, and so up here, let's go ahead and apply a transform. Scale bar. Oh, but distance is going to
be big.
Yeah. What is? Yeah, let's just do that for now.
This is gonna be hilarious. Oh, element.set style.
Yeah.
Oops.
There you
Looks
go.
like, is our mouth off?
Okay.
Okay, nothing's happening.
Getting an error still. M.element. Oh, that's still. Char measurements.
All right, I think my math is off. No, it shouldn't be. We have x2 minus x1, y2 minus y1. Can you see what the, actually I'm going to console.log here too, but we could also.
Distance is none. Currently.
None, great. So, so it's probably because.
Oh, right.
Yeah.
And it needs to be rect.
Oh, yes, you're right.
Just dot left. Rect dot top. Minus client y. Okay, that should. Whoa.
Oh my god.
Yeah.
Something is huge. So let's do, yeah, just divide
like
by
that. I don't know if that works at all.
Let's, well, so
just
yeah.
scale it back.
Oh
there,
gosh.
Hey.
Whoa.
That's already such a cool effect.
That was easy.
Yeah, that's awesome.
So, that is so cool.
Yeah. So right now it's kind of inverted.
Right. So we have to probably do like 400 divided by our distance and see how that. Oh my gosh.
Oh boy.
Oh, wow. Okay, so we need to adjust the math on this a little bit, but this is the right idea. This is hilarious.
Yeah, we can take the borders off here. Display inline grid. Center.
All right, so let's think this through. When the distance is 0, we want it to be a set height. So, or sorry, font size. Or sorry, scale. You wish you could do math.max in there.
Yeah, what is it? Isn't there not a max within calc, is there? That's only for grid, isn't it? Min-max?
Math this out. So 0 goes to, like, let's just say that we scale it by, I don't know, 2. And so the further away it gets, like if it's 1,000 away, then we want to go to 0. So, yeah, this is becoming a math problem.
It always does.
Okay, so yeah, I wish there was min, max value. all that fun stuff.
Yeah.
Math portion. All right, now I'm going back to middle school math again. So because I want to say 0 is to 2 as 1,000 is to 0, or something really, really small. So 0 to 2. No, I don't want to do that. All right, drawing in math. This really brings me back to I don't know, algebra, middle school, high school, whenever you took algebra. So when x is 0, y is 2, and then it goes down. So the slope is going to be, don't worry, I'll figure this out. 2 plus, and then the slope is, what do we want to be like the maximum distance? Just give me a big number. Like 1,000 or so.
100 viewport units.
Not sure we could do that, unfortunately. I really wish that we could, though. Or could units cancel each other out? Like if you do pixels divided by viewport units, does it give a unitless value? I feel like someone's smarter than us in the.
Sorry, say that again.
So if you do like 100 viewport units, like 100 VW divided by 100 pixels, what kind of value will that return? Will it return a unitless value?
I believe everything resolves to pixels.
Okay. So 2 minus.
Calc, do min.
Two minus 1. So 0 minus 2 over x sub 2 minus x sub 1, which is 0, negative 2.
Let's see. In the chat, min is available, but max is also a thing too, right?
All right, I think I got it, and I'm embarrassed that I took too long to figure out this algebra, but okay. I'll just do it down here. Transform, scale, and so basically we want 2 minus 2 times var distance divided by 100. I think. Let's find out.
I'm getting an error here. I'm missing a.
Oh, did I forget my calc?
Yeah, give it a calc.
Okay, oops, parentheses, come on.
Oh boy.
Perfect.
It looks
are
like
some of them upside down?
yeah, so I think we need min here. So min or max 0, comma, that should work. Because I think what's happening is it's negative. Okay.
Oh,
this is a silly Sass issue where it
Did
tries.
we forget parentheses or
no?
something?
Sass tries to aggressively use like its own functions. Right. So it's got to be like that, or just for the. Let's see. I think it's for the whole thing. Wrap it like that.
Yeah, I forgot how to do the interpolation syntax.
Yeah.
So I think we need to.
I get it.
You know what?
Unquote.
Yeah, which is very silly, but you know what? If it works, it works. Are my parentheses right?
Maybe. Oh, yep. If you hover over, it's working.
That's hilarious.
Nice.
Okay, so I'm guessing we don't want the min distance to be, or the min scale to be 0 then. We probably want it to be 1. So
Yeah.
back to the mathy drawing board. Let's see.
Well, no, we do want at least close to 0, but we can set that with the max here as like 0.25 or something like that. And then
okay, let's try that.
Then when you hover, the thing is we want like a bigger distance calculation. So is that in the division? Yeah, it is. There we go. Nice. And
probably smaller.
Yeah. Well, that's just in the 1 and 1 right there, right? Yep. Right. So in this case, this 1 is kind of the max scale there. And so we can do that. Nice.
All right, cool. Now, we also have to account for when the window resizes, just because I'm seeing a little bit of weirdness.
Right.
So I'm going to put this char measurements, or actually, yeah, this figuring out of measurements in. All right, so let's do this. Let's char measurements equal that. And then we're going to have a function. So function get char measurements.
Okay,
and this function.
Speaking of math, Lewis in the chat is saying, I still think the easier route would be to calculate the square/rectangle diagonally and divide your distance by that value to get a normalized distance.
I mean, we can play around with that if you want.
Right. Yes, that looks good. Yep. And then just a window dot add event listener size. Go. Our resize should work correctly.
All right, so we have function get char measurement and then function recalculate distances. I'm just going to call it that. And the reason I'm doing that is for the whole window resize stuff. So I'm going to put this in there. And since we don't have that client X and client Y, I'm going to replace that with mouse chords.x and mouse chords.y. So mouse chords.y. So now everything's broken. Oh.
Yeah, that was, well, it's still broken, but yeah.
Recalculate distances. Hey.
There we go. Oh, it's back.
Ooh, that is nice. Okay, so window.add event listener resize. We want to
I've already got that up here, but we can
okay.
And then yeah, so that logic itself should be working. We don't necessarily want to recalculate distance until the mouse moves again, because
that makes sense. Okay.
That mouse position is going to be completely different.
All right, so I just shrunk it. I'm making it big again, and it looks like it works with the window resize.
Yeah, very nice.
So now I'm going back to the original animation just to see if we missed anything, and it looks like we don't. You know what? The point about normalizing is actually a really good point. So basically, the normalization means, give it a value of 0 when it's furthest away, 1 when it's closest, instead of doing all of that, like assuming it's a big value up here.
Right.
So, yeah, we could do that using my algebra.
So doing that in the JavaScript.
Yeah. I remember the old framer had like clamp as a utility. for this, but we could actually, just because it's really, really useful. I'm just looking for a quick little gist to do that. Well, no, I don't want clamp. I want, you know what I'm talking about? Framer.
No.
Okay, it's not clamp. It's interpolator or something. Never mind. You know what? We're going to do this manually. Okay, so distance. So constant normalized distance. That is going to be the 1 minus 1 times distance divided by 200. So basically, I'm moving the math from the CSS to the JavaScript, and then we're going to put the normalized distance inside. So over here, instead of this ugly stuff, we have just a normal, distance. So we don't have to do that calc stuff. I hope this works. Looks like it still works, right?
Yes. It's
all right, cool. So our CSS is greatly simplified, and now we have that value between, well, 0 and 2.
Lewis is saying no need for the multiplied by 1. We can just do 1 minus the distance.
That makes sense. All right, so now it's basically a value between 0.25 and 1.
Yeah. Can do that down a little bit more, and then we get a little bit more responsiveness. Let's see. Kind of.
Wait, that's going to mess things up, I think.
Yeah.
But yeah, we could simplify that even more, and now we don't even need unquote here because, yeah. Did that work?
No.
Weird. Okay, maybe, oh, geez, okay. I forgot, like when you're doing custom properties, that's when Sass says, okay, I will leave this alone. So we could just use max. So weird. I just wish that all of the Sass stuff just made it to CSS already.
Yeah, it's just not consistent. We're working on updating to the latest Sass. There's that some of this is fixed in the latest.
Yeah. Well, what's cool about this is now that you have that property, you can even do opacity, far D and.
Yes.
Oh, that's so cool.
Yeah, and okay, so Lewis is also saying, and the diagonal is math.hypot container width, container height, rather than just 300. So if we do, L, let's see.
Okay.
Container rect equal get bounding client rect. There we go. And then so we can do let's see, diagonal equal container rect width divided by math.hypot container width container height would be this value here. Diagonal.
Lots of math here.
Yeah. Right, and we could maybe even divide that diagonal by like 2. Give a little bit more, yeah.
Nice.
Keep it a little bit more like a spotlight. Yeah, that's really cool.
I dig it.
Yeah. Okay, so let's see. Did we meet our 30-line guarantee?
No, we did not. We blew right past that. But we
Uh,
didn't use any libraries. Actually, well, yeah,
right. So we could simplify in a few areas. Like we don't need the external mouse chords. We can just oh, recalculate distance. That's only being called here, so we can actually move that inside. Well, let's pass through.
Or yeah, we could
Just pass
just
through
yeah,
that.
yeah, good
And
call.
then
That's what I was
say
thinking too.
mouse chords. That should fix that. Nope. What's it complaining about? There we go. Okay. Great. And then why do we have an error? What's error? Mouse chords is not defined. Yes,
I have nothing here.
Okay. I think it's just not out for me. And we don't need that other distance calculation. Can leave that off. Go.
I thought we do for that.
Oh yeah. Sorry.
Yeah.
Yeah, I guess we gotta leave that in. Yeah, I mean, we technically don't need char total here, so that could be removed. We're still, maybe 10 or 15 lines over, but
yeah. Lewis also says one last thing you could try is doing normalized distance times normalized distance to get that scaling effect. So where's that? Oh, here we go. Normalized distance times normalized distance.
rather than dividing by 2, or is like it's peeking in from the other side.
Oh, that's weird.
That's cool.
Not sure if that's the intended effect, but that's
that's kind of what the no, it's not exactly what happens in the other one.
No, so I think we need to do a min there, or something like that.
Well, I think just removing that works fine. Because I've got. Oh, you're talking about
the
to get an
power
easing effect,
scaling,
right? Yeah.
Oh, Lou said no. That's not the idea. Help us out.
Yeah, we need to just get Lewis on here. Let's see, font size. Get more of a spread there. We could even increase this to like 1.2 and get those really spread out.
Ooh, nice. Yeah.
Right now it's kind of linear, and so that's what the normal.
So yeah, that was the idea by normalized distance times normalized distance.
Right. Right, which is cool.
Better, but it peaks from the other side, which I'm not sure why.
Remove the divided by 2 here. Yep, that does it.
Yep.
Yeah, it's still
linear-y.
Yeah. Yeah, I lean more towards just dividing by 2, keeping it a little more focused. But yeah, I do like the trying to make it a little more linear, or a little less linear.
Yeah. I mean, that's a good effect overall.
Yeah,
that's what we have here.
I'm quite impressed for relatively few
yeah,
characters here.
And honestly, if you had splitting, then all this would, well, that's only like 10 lines. That's really nothing.
Right. Overall, that's probably the simplest part of this. Let's see. Let's add a nice little font family here. Get it away from Arial or whatever we're doing. It's nice. Oh, I'm getting that peak effect still. Oh, okay. You multiply by 2.
I don't know why the peak effect is happening. I'll be honest with you.
Yeah, it's one of those things that if you're looking at like the raw numbers, it probably makes sense, but just looking at the output effect is really hard. And that's not something that we debug very well on the show a lot of times, because it's just so boring to look at raw numbers. Yeah, I don't know that it's okay.
Now it doesn't work at all.
Well, now it's doing the opposite.
Oh,
Let's see. Math.abs.
I don't know if this will work either.
Might be math.
Oh, geez, still peaking. Okay, yeah. But yeah, people could play around with this and see, what they want to do.
Oh, because we're still dividing by half, but it doesn't.
Yeah, try getting rid of that and then seeing what.
Yeah. So
okay, no more peaking.
Still does that, yeah.
Which is good.
Yeah. So it still feels linear to me. It's just spread more. So math. Yeah, he's saying math dot max. Whoa. Normalized distance.
Okay, that feels better. Yeah, I feel like we could play with that all day.
Yeah. Oh.
Ooh.
Is the double asterisk short for POW?
Math.pow? Yep.
Nice. All right. I mean, that's pretty cool looking.
It's cool. Yeah.
Yeah. Okay. Anything else we need here?
No. I mean, the effect was pretty quote unquote simple, even though it did take a lot, but we got it. So
yeah,
it's great.
I mean, the actual like implementation of it is pretty straightforward. It's the math of it all that gets
a little bit hairy. Like if you sat down and used pencil and paper, then you'll figure it out.
Yeah.
But there's only so much my Monday brain can take.
Right. 3. Oh yeah, there we go.
Wow.
Yeah. So
actually like that more.
Yeah, upping the power calculation helps a lot.
Let's go back to this real quick, see what happens. That does nothing. I don't know why I thought that would work.
Sorry, I broke the CSS. Just a moment. Go.
Here we go. And so this is using the normalized distance times normalized distance, which was originally recommended. So yeah. But yeah, I mean, definitely we could play around with that and see.
Yeah. Yeah. I want to go through and like trim as many lines as possible, but I don't think there's a point to that. I think this is in a really good spot in terms of simplicity and readability.
Yeah.
So yeah. Okay. So there's a I think we can simplify this and kind of go over. Oh.
Yep, just playing around with that.
Oh, doing an actual color change.
Yeah, I'm not sure how, that's probably not working like I wanted to.
You're wanting like a color shift.
Yeah, something like that, but I think you have to do 1 minus var here. I don't know. I knew that there was some RGB.
Ooh.
Oh, well.
Yep.
That's it.
Yep, that does it. If you use your out, then you can go from red and green, get a nice Christmassy effect going on.
Hey, I like the Christmassy effect.
Yeah.
You know what?
If you do, HTML background. Um,
Oh
make
gosh.
your eyes bleed a little bit.
Yeah.
But you know, something like that.
Maybe not.
Well, just a little bit of green there. What if you add CSS Transition on the letters? That's not a bad idea. Transition. Let's see.
Now, so for transition, this is where it gets a little bit weird, because if you're moving your mouse all the time, then you're having a transition that happens all the time, and then it gets a little bit weird.
Right. It does kind of cause an effect. It's not as noticeable here. At least I'm not seeing it.
Feels like a delay. Like I think we do like even something as low as 0.1 seconds, then feels a little bit better.
Right. Well, what you can do is something like transform 0 seconds, and then like opacity or color, something like that, and then you get kind of some instant feedback along with like a slower change.
Yeah, I really like this color shift though. Red to green. Nice.
Yeah, speed that up a little bit. But that does give some more dynamic effect to the change there, while still giving that instant feedback. But the color shift, I think, is going to happen a little bit smoother than the transform, like in terms of the browser transitioning that.
Nice.
Yeah,
Play all day
I mean,
with
I
this.
guess if we're just targeting color, we can just do it that way. Yeah, that's super cool.
Cool.
Yeah, I dig it. Anything? Yeah. Anything else on this one? I think we can.
I think we've done this one to death. Yeah.
Well, what would you like to summarize here?
So, CSS variables for one.
Well, yeah, the like splitting light idea.
Yeah, for sure. The splitting light and the normalization of values for CSS variables. Like instead of doing those, 400, 200, whatever, just having it between 0 and 1, making it nice and simple.
Yeah. Absolutely. Okay. Yeah, I think that is good. Okay. All right. So yeah, if you're watching live, thanks so much for sticking with us. And don't go anywhere. We're gonna kind of summarize what we've done here to make it easier to digest than the full hour-long show. So we're gonna give some summaries here. So stick around. Go. Get ready for the intro, David.
Okay.
Hola, amigos, and welcome to Keyframers. I'm Stephen Shaw.
And I'm David Khourshid.
Let's take a quick look at a technique from this text grid with mouse interaction animation. So one of the things when we're doing text-based animations, we normally reach for a library that I wrote called splitting.js that basically divides text into spans and gives you helpful CSS variables, and that's awesome. It works really well for a lot of things, but one thing it does is it also wraps words in spans, and there's a lot of reasons for that I won't get into. But if you ever just need the like raw text converted into spans without worrying much about words or anything like that, for a text grid effect like this, that's all you need. So I wrote this splitting light function that was kind of like the prototype for what splitting became, where you pass in an element, it pulls out the inner text, and then it splits that by nothing, which basically means give me every character. And then for this, I'm filtering out any spaces or anything like that to just have like the words repeating right after another. And then we're mapping through all of those where we have the character that's, K or Y or whatever. And we're kind of returning this HTML string that we then drop into the inner HTML there with characters.join. And then we're also passing through a CSS variable for the char total. And each of the chars gets a index variable, this I variable. So that's a really easy way to just do some text splitting. If you don't want to pull in splitting.js, or you have a very specific way that you want to handle that, you can just do that. And we're able to now style all of those characters individually. That we're doing a bunch of calculations later down the line. But with display inline block or display inline grid, you can start to transform and do a lot of fun things with those characters, including doing an actual grid layout. So for the container, we've got display grid on there and grid template columns, so that we get this really nice lined up and grid layout for each of the characters. And then with display inline grid and place item center, the actual characters themselves are centered within that grid. Yeah. Okay. that's it for that one. Let's talk normalizing CSS variables. Will you get us into that one?
Okay, so you might have noticed that the only styling that we're doing in the JavaScript is setting CSS variables. And like we've talked about in many episodes, this is good for a number of reasons, mostly because you could use those raw CSS variables and do whatever you want with them in the CSS rather than applying the styles directly in the JavaScript. Now, something that you do have to keep in mind is that when you're passing values over from JavaScript to CSS, it's best to what we call normalize those values. So we are calculating the distance here, and yeah, so this distance ends up being in pixel values, anywhere from like negative to positive, like 400 or 500, or just these really big values. And honestly, for our purposes, we don't really care about the raw pixel values. We just care about this general, how far is it away from the mouse pointer? And so instead of sending those raw big values, we normalize it so that the value is between 0 and 1, or -1 and 1. And when we work with those values, things become a lot easier. So that's our normalized distance over here. We do 1 minus distance divided by the diagonal. And this diagonal is just the container, or yeah, the diagonal of the entire container, just so we could see, how far it is from, that long
kind of
line.
Center, basically.
Yeah. So on each one of our characters, we set the distance CSS variable to that normalized distance. Or actually, right now we're playing with, just having a nice like exponential whatever effect.
Right. And instead of like a linear scaling, kind of ramping it up to like a easing curve. So that this is essentially a math.pow 2, or to the power of 2, that normalized distance.
Right. Yeah. And, it's still going to be that normalized value. So in CSS land, we could use that distance directly. And over here, we're doing a little bit of pre-work. We are just making the distance max 0 or I think it might be a negative value, but,
well,
max
so
0.2.
This is just a fallback value for the distance. The max 0.2 there is just so that the letter doesn't completely disappear. You can see how you know, it's hard to point to it with my mouse pointer because they keep changing size. The ones furthest away from the mouse are still visible. They're just they're just small.
Yeah, which is confusing because it seems like max is really for min and min is for max in CSS land. But we'll talk about that, you know, some other episode. Anyway, we take that D value, and now we could do things like change the scale here. So we're passing that D variable into scale. We could change the opacity. So we're changing, you know, since we have that value, you know, that goes up to 1. We could pass it directly into opacity, and we could do more fun things like pass it into RGB, which does accept CSS variables. So we could pass them in directly to the red, green, and blue values. I guess we're not doing blue, just red and green for the holidays.
Yeah.
So yeah, using normalized values is really, really useful for just being really creative with those values once you have them passed from JavaScript land.
Yes. Yeah. Just dealing with 0 to 1, or it's essentially a percentage, or I guess decimal is the more correct term, value that really helps you just drop it in wherever you want, and you don't have to worry about like extra calculations in the CSS. If you can handle that elsewhere or just in another CSS variable, at least, like, you know, instead of there, just like normalized D, and then doing all your fun calculations there before you drop it in something like the transform function or something like that. That helps so much in keeping your CSS clean and making it kind of understandable and easier to follow.
Mm-hmm.
All right, will you start the outro there for us?
Sure. You can watch the full process of creating this animation for a deeper dive into each technique on the full live stream linked right below. Leave us a comment if you have any questions.
Our show is supported by our sponsors, CodePen at codepin.io, CSS Tricks at css-tricks.com, and viewers like you. You can pledge at patreon.com/keyframers and subscribe to our channel for more great content. Got plenty of links available below for you. Well, thank you all so much for watching. Until next time, adios, amigos.
Adios.